Hi, today I'm going to talk about this question. This is a question taken from Yio Chu Kang Secondary School, EOY 2018, and it's for Secondary 3, A Maths. Question says, given that 3x cubed plus 11x minus 4 out of the product of x squared plus 4 and x minus 1 can be expressed in the form indicated for all real values of x. Question wants us to find the values of A, B, C, and D. Looking at this original expression, you will realize that the degree of the numerator is actually 3. That is the highest power. And the degree of the denominator is also 3, because when we take x squared, multiply by x when expanding out, it ends up with x cubed. So with the numerator and denominator having the same degree, we have to recognize that this is an improper fraction, and we will have to do long division in order to simplify it and change it into a partial fraction. Let's see how we do it. So first step, I'm going to expand the denominator. Next, I'm going to do long division. So 3x cubed plus 0x squared. You realize x squared term is not included in the numerator, so I have to put the x squared term in, plus 11x minus 4. So you divide by, in this case, the divisor, x cubed minus x squared plus 4x minus 4. Okay, then I have to ask myself, what is that number up there in the quotient that when I multiply by x cubed, I will have 3x cubed? I always would want to eliminate the first term inside the dividend. Dividend is a number within the division sign, okay? And that is 3. 3 is a constant. I will write it right above the constant under dividend. So as I multiply out, I will get this. And I do a subtraction. I will end up with okay. So what have I ended up myself? Where have I ended myself at? 3. 3 is my quotient. And I look at my remainder. My remainder will be the numerator of the fraction, which is 3x squared minus x plus 8, out of the denominator, which is x cubed minus x squared plus 4x minus 4. But instead of putting that down, let me put the factorized form. Okay. And what is the factorized form? You will have seen that this form was actually taken from here. So I'm going to write the factorized form in the denominator. Okay, now, next part. I'm going to apply partial fractions on the fraction itself. So looking at 3x squared minus x plus 8 over x squared plus 4, x minus 1 in particular. It can be further broken down. What do I break it down into? Well, I have bx plus c over x squared plus 4. So I'll just copy down what the question asks of me. Plus d out of x minus 1. Okay. Exactly in the form, the denominators also match. Now from here, I need to make sure that the denominators are all the same across from left to right. So this means that my first term on the right hand side, top and bottom needs to be multiplied by x minus 1. Okay, and for the second term, I need to multiply top and bottom by x squared plus 4. So it will end up something like that. Okay, now what does this tell me? This tells me that the denominators are all the same, and because they are all the same, I could just focus on the numerator and compare them left versus the right. So therefore, 3x squared minus x plus 8 equals to bx plus c bracket x minus 1 plus d bracket x squared plus 4. All right, now looks like we can find what the letters stand for at this point. Is there a particular value of x that we can substitute in order to find one of the missing letters? Well, we always look at the factorized form on the right hand side, and we realize that at this point here, if I allow x to be 1, this entire term here would be 0. Okay, so I let x equals to 1. And on my left hand side, it would be 10 equals to 5d. Okay, and that works out to d equals to 2. That's my value of d. Now next, I realize that I cannot substitute any more values of x so that I eliminate an entire term. So what I could do next is to compare coefficients. Now let's compare coefficient of x squared. Okay, now on the left hand side, my x squared coefficient is 3. And on my right side, my x squared coefficient would be b, add to d. So it will be 3 equals to b plus d, but we know that just now we found out that d is equals to 2. So I substitute the value of 2 in there, and therefore b equals to 3 take away 2, which is 1. Next, let's compare another value on left and right hand side. Let's consider constants. So comparing constants. On the left hand side, we have 8. On the right hand side, we have negative c plus 4d. So therefore, we could say that 8 is equals to negative c plus 4 multiplied by 2. So 8 equals to negative c plus 8, and therefore c is equals to 0. We are left with the value of a. So what is a? Well, a is a value on its own that is not a fraction. It's not fractional. And you realize that whatever partial fractions that we have came up with is with regards to this side of the expression. So therefore, a has to be 3, isn't it? So a equals to 3 based on that comparison. In conclusion, a equals to 3, b equals to 1, c equals to 0, and d equals to 2. That's the answer.